Welcome back, everyone. We're going to continue with the program, and next to me you see Cesario and Sandra, and they're going to talk about scaling Scrum at Thales. The floor is yours.
Thank you. This works. So, welcome, Nana. My name is Cesario Ramos. I'm going to share with you a story about scaling Scrum at Thales. I work as an Agile coach across Europe, and I'm here today with Sandra Roijakkers, who is a cluster manager at Thales, and we will together guide you through this adoption journey.
Next slide, please.
I'm
Sandra, you saw my picture and you see me. I would say a few words about Thales, what we make, both because I'm very proud of our products, and I think it's useful to know that we are not a startup company or a Google company or not a banking company. We make a very special systems, what everyone says, but we really do. And we have our organization adapted to that. Thales is a huge company, 70,000 employees all over the world. And in short, we do everything where safety and security are critical.
You can use the button. Yeah.
Okay. Then I zoom immediately to our part in Hengelo, the Netherlands. In the Netherlands, Thales has about 2,000 employees, and Hengelo about 1,500. And we have two main business lines. The most interesting one is the surface radar business line. We make radar systems and sensors for marine defense systems and on ground-based defense systems. And then we make a very broad range. In the middle, you see the Squire. It has recently had an extended functionality so that it can detect drones at 2 kilometers distance. It can detect it much earlier, but then it can distinguish those drones from birds. And currently we are developing the Smart L early warning capability radar that will be able to detect a ballistic missile being launched at 2,000 kilometers distance. And that whole broad range of radar systems is developed by a business line of about 600 employees, a lot of politics and all those commercial guys, but 300 people that do the real development of all these radar systems. A few words on how we work. Like, in fact, every company, we have the engineering and architecture department that defines the total radar, the functionality and the architecture. And then the work is done in 3 technical units: the mechanical and electrical, the analog part, and the digital processing. The digital processing department is about 70, 80 employees. That's where I am one of the managers, and that's the part that we are going to talk about, that we are now working as one Agile, skilled Agile team. First of all, agility in a defense organization is quite difficult because the customer contractors are fixed scope, fixed price, fixed functionality. And we have to make a fixed price quotation for the work we will do. So you would say, yeah, don't think about agility. But for various reasons that I will come back to, we wanted to go to Agile development. And we can do it because we have that budget and the lead time, that they are fixed. And the end functionality, as the customer sees it, is fixed too. But within that, together with the surrounding departments, we have quite some freedom in how we realize those customer requirements and how to optimize the customer expectations. Now we will zoom into our department and what we do. And to avoid the risk that I will use 2 technical terms, Cesario will explain what we do.
All right. So I will explain to you what a radar is. So a radar is very simple, as you can see, and it's quite different from information systems, because I've done also a lot of information system processing. But basically, it's about sending out radar signals. So we have to just do with mathematics and with science and so on, physics. But you send out radar signals, and then somehow they bounce off objects in the air. And then they bounce back, and you pick them up. Then you have to do a lot of mathematics again, and then something will happen. Some information can be distilled. You can distinguish between a flock of birds and a drone, or between a Boeing 747 and a missile. And after that, after you have that information, you want to know, okay, is it coming towards me maybe? or is it going in another direction? And in order to do that, you can imagine the architecture is a bit complex. These are all the components that are there, all the software components. And at the left side, you can see sensor management, and sensor management is about distinguishing which waves we need to send. It has to do with the weather and so on. And then we have FPGA, that is very technical. It has to do with programming chips, but really programming chips, right? And then you have signal processing that has a lot of GPUs, so to do concurrent processing, they need to process, for example, 4 DVDs of data every second. And then it will take out a lot of noise, for example. And then it goes into another filter who's going to take out more noise and put it into information. And then afterwards, there is another component, for example, tracking, who says, okay, the missile is there, and now it's going there. Probably it will be here in 5 seconds, so that you can make tactical decisions on it. So initially, Thales makes 3 products, for example, in parallel at any time. They work with project teams, as you can imagine. Most of your companies also work with project teams, I assume. And that gave some problems, because one project team, of course, was optimizing their own project. And, but it was one radar still. It had some differences for customer I, customer Z, and so on. But most of it is a shared code base. So there was a lot of code duplication, as you can imagine, because projects were all fighting for their own goal. Because of the mathematics, right? You cannot find a bunch of them. It's not abundance of mathematicians that can do the mathematics. So if a mathematician, for example, would be on vacation, you could potentially have a problem with your project. So there was this single point of bottleneck problem. There was this code duplication problem, and so on. So they decided, okay, we need to do something. And we've heard about these agile things. It works in internet companies, we've read, so let's start doing some pilot projects. And they did, and it worked. And then they said, okay, it works, so now we're going to do it with these 100 people, with these 90 people. And of course, traditional wisdom, Taylorism, for example, said, okay, we have to specialize the work. We have all those components, so why don't we create teams around those components? Right? It's easy. So a team full of mathematicians doing the tracking, and so forth and so on. And that was the first structure change. And of course, we had a bunch of managers still left, just like Sandra is one of them. Sandra is one level higher. What are we going to do with the managers? Of course, there's this PO role in Scrum, and they can be POs. They can manage the backlog and talk with customers and coordinate across teams and all those funny things. And that's what they did, actually. And another thing that what they were doing, for you to see the context, of course, they were using the V model. I assume most of you are familiar with the V model. So they were doing Scrum. We like to call it mechanical Scrum at Scrum.org, but I don't like that term. I just call it fake Scrum. It's just fake Scrum. And they were doing Scrum only at the team level, and all the teams were working as a team. So it's fake Scrum, Scrum butt, whatever you want to call it, but that's what it was. And then Sandra and I got in touch somehow, and then...
Now, in fact, I said before, I will come back on the reasons why we did Scrum, and on the next slide. We had those Scrum teams. I thought at that moment we have the perfect organization, because all those specialists, they cannot easily take over each other's work, so we need to have this organization. And we have indeed the transparency in what they are doing. We have the knowledge sharing, no single points of failure. So everything can wait and see it happen. And that the teams become better and better, continuously improving. And we should have happy customers. And we didn't have. So I was looking for an Agile consultant. And then Cesario, and I asked him, well, there should be something done with the engineers. It must be them. The organization is good, the engineers, they are doing wrong. They must have get a better Agile mindset or something. Cesario, help. And then Cesario came in, oh no, you're organized wrong. I said, no, Cesario, you don't understand it. We need this organization. So we had a lot of discussion, but it was interesting. And in the end, we hired him, all through didn't believe what he was saying. But he really challenged what I was saying. And the other consultants that came, oh, yeah, yes, I understand. We need to have workshops with the engineers. Didn't feel good. And Cesario seemed to know what he was talking about. And then he explained to me, you have those component teams. They do their work, but what they are doing has no customer value. And do you remember that first principle of the Agile Manifesto? It should be all you do should be done to give the customer something that has value for him. And what you're doing isn't. That was really an eye-opener for me. And for my colleagues. It was not only me. So come back to this organization that we had. Why didn't it have customer value? We had those project requirements, the various features. We didn't call them features yet. And the feature was brought down or split into work for each component. So to realize feature 1, those crosses had to be done. To realize feature 2, the next one, then feature 3. And all those teams worked independently on their part of the feature. And 3 months later, it was integrated and tested. And then the engineers were annoyed that they were disturbed in their current work. But all those teams just worked independently on their pieces of the work, which had in itself no customer value. And for example, to realize feature 3, it can be that the first component team picks it up in 2 months' time, while the other team is already working on it. And the teams were out of sync. And what we even had is, that's I think the next slide, when teams were far ahead of the other ones, they were working on parts of a feature that they thought, well, this will be needed, I think. And later on, the feature, of course, changed, and they had to redo a lot of the work. So they were each optimizing their own efficiency instead of optimizing the flow.
Yeah, great. So, so we had this, right? So, and if you look at the organizational structure, you see all those component teams, and then, of course, the question to ask is, why did Ken leave out the tester role, right? Because there's a development team. Where are the testers in Scrum? They're there. Yeah. That's because, of course, as you know, quality testing is everybody's responsibility. That's why there are no testers. But who's going to do testing here? Which team? You know the answer. That's right. It's the testing team, right? Who will do the testing. And who? Oh, but which team will do that?
Every team has its own test capability.
Oh yeah, of course. Yeah. And who will break down the architecture, the requirement into individual tasks? Architecture team, right? And so forth and so on. But even more interesting is, who will coordinate all this mess? The project manager, of course, the good old project manager. He has to keep track of what is this team working on, and why is this team working on a feature that is of low value? How do I push you to test first so that I can integrate and so on? So those poor project managers were there, and that's what they had. They had those poor project managers, and they had those poor software integrated test team, and they had those poor...
They were not poor.
Okay, they were rich, that's true. But poor in terms of, wow, your work really sucks. Yeah. And they had these processing testers, and then they had these system testers. Because system testing, you have to realize but Thales makes software and the electronics and stuff that weighs something, iron. And that's the system that needs to be tested when it's constructed together. It's not just software. So that's where the system tester came from. So they had all these problems. Local optimization, unnecessary coordination, delay of integration, so bugs, etc. costs a lot more than it should cost. So we decided to change something, right? So the 4 things that we changed was, okay, we need to change the organizational structure. If you really want to go to Agile, or what this gentleman called this morning, the loops, the holistic loops, right, from holacracy, you have to change the structure. You cannot remain that. You cannot have that hierarchical structure anymore. You have to change some policies, some working agreements, and so forth and so on. So that's what we started working on. And one thing that people often forget is they take the Scrum part, for example, they take the project management part, but they don't do anything about the Agile engineering skills. And then, of course, this gentleman is nodding here. I know him. He's an expert on .NET, if I'm not mistaken. It doesn't work, right? You forget that. So what we did is we created a shared vision. We started with management and then started getting approval and contributions from the people of the various teams. And the idea was, okay, within 2 years, we want to go from where we are right now up the V model. So the next step would be to increase the V model. So every sprint, instead of just being able to deliver a piece of working functionality from one component that is valueless, we want to deliver one integrated piece of functionality. And the next step is, okay, now that we are delivering every 30 days, it's not 30 days, but 4 weeks, working functionality, we can eliminate the integration team. So the hierarchy becomes flatter. That was the next step. And it's working right now. Now, after we are able to do that, every 30 days, deliver integrated functionality across all teams. Without an integration team, we need to increase again the next step. Take into account the functional testing, so testing the software and the hardware together, seeing if it really detects the missiles and so on. So this was the plan, and it created this focus, this vision, this change vision, where we wanted to go. It's one of the very important aspects of the change. The other change was, okay, within this change group, we eliminated hierarchy. We changed it into a networked structure. So you can see that the head stands in the middle somewhere, and line managers, just like Sandra, stand around it, and they coach, for example, on communication between the teams. Instead of, as you can tell, she can tell it much better than I do.
Some of my colleagues just didn't like the new job of coaching, and I liked it, and I followed the coaching course, and yeah, some changed, and some found another position within the company because the company is large enough. Now, there are a lot of positions.
That's a good reason. Yeah.
There are a lot of positions in which the coordination is still needed, and those managers who like to coordinate and steer can find another job within the company, and they're doing well in that. So, in fact, this summarizes what we just said. I don't know if we need to read it aloud.
I think it's cool.
Maybe only the second bullet, because the department head, we have to have one prioritized product backlog. And we have various projects. So someone has to create one product backlog out of that. And that's the task of the department head. He's also involved in the Scrum process, has an important role. And he fulfills the product owner role.
So, and I want to add to that a little, so just one sentence. So I like to, he's not a product owner, right? We just call him the product owner. Okay? So, I like the term, it's a temporary fake product owner. I like to use that term, and I got it from Craig. So it's a very good term. It's not the product owner. It's just, okay, we have to do something now. We can just stop working, or we can continue and then expand the change. So who's going to be PO? All the department heads became the PO. Temporary fake product owner.
So, in fact, I will explain in somewhat more detail how we changed from those component teams working on their individual parts to the department sprints. And then I made this drawing. For the outside world, as a project has still releases. They are planned, they are scheduled ahead. We know on October 1 we have to deliver this, and on December 22 we have to deliver this. These are the fixed releases with fixed functionality, more or less fixed, there's some discussion possible. This release functionality is broken down in features. Features are things that have value for our internal customer. And each feature contains stories, work, for one or more of the component teams. Because the component teams have their own specialization, so in fact each story in principle has to be laid down at one of the component teams. So for one project it is quite easy. The difficult part was making the feature small, because in the beginning it was, oh no, at least 4 months of work, otherwise nothing has value. But now we managed to have several features in a 4-week sprint. And for one project, we organize it like this. We have the features ordered, and the work for the teams is defined in feature refinement sessions. The next step is in our department sprint planning. We have to say 3 projects in parallel. They all come with their lists, ready to fight, because they all want their work to be done. And then we have them together, those external project managers, together with the department head, and they decide on what has really the highest priority. Okay, you wanted to finish this, otherwise that guy gets bored, but you want us to finish this, because next month the customer comes. Okay, difficult decision, but I think that has highest priority. So we have now the fine-grained priority setting in features. Before we went to very high management, and he just said, this project is more important. But now we can decide on the relative priority of the various features.
So can I add one sentence to that? So I think the thing that Thales did is very interesting. So instead of doing big batch prioritization, so which project is better than the other one, because they are working on, from a code-based perspective, it's one product. So if you consider it one product from Thales perspective, you can order the projects more fine-grained, right? Make sense? Instead of doing one project more important than the other because they are doing the same project, we can choose features of the various projects and combine that into one sprint. Just because we take a broader product definition. Make sense? This gentleman nods, so it makes sense.
Okay, then all features that are candidates to become in the department sprint, they need to be refined before the sprint planning. So when that first part is finished, priority is set, it's very fast that all the teams see how much they can do. So we plan in, and when one team is fully loaded, okay, we stop. Or we know, after a few cycles, we know how many feature points, that's difficult calculation on story point velocity and so on, how many feature points we can handle within one sprint. So we stop with adding new features, either when one team is loaded or when we reach our velocity. In the beginning we said, oh, well, when you are fully loaded, but maybe you can help a little, and then you can use this, and we fully loaded all the teams, and we never realized our sprint goal. So later on we found out, don't do that. We know we have this velocity, we need some slack in the coordination between the teams, so we stop at that lower velocity, but now the last 4 sprints we made, and before that we missed a few feature points, but now we can really do what we promise. It was also something, better not fully load them, but make realistic promises and make it come true.
Yeah. Those were hard discussions, right? Saying, okay, you have these people that it's good. It's okay if they work only for 3 days a week. It's okay. It will go faster.
Yeah. They do other things, but that's...
All right, so this very complicated picture is what we do. But what we see here is just Scrum. It's just one PO, it's just one product backlog. It's one sprint planning with 75 people. The sprint planning is just broken up into 2 parts, right? Like, what are we going to do with stakeholders that Sandra just talked about and team representatives, and then how are we going to do it? But then the teams pool their work and do their sprint planning as usual. And then instead of having a daily scrum per team, they have that still. There is still a daily scrum. We call it a scrum of scrums. You can call it whatever you want. It's a meeting, 15-minute time-boxed meeting, where representatives of all the teams get together and inspect daily dependencies and where they can help each other and so on and so forth. That's the big picture on the front. And then, of course, what Sandra said, there are these two refinement meetings where teams can actually, in the first wave, they say, okay, this is the stuff that we need to break up. Let's break it up. We need to estimate this. Let's estimate this. And then they can also already make a pre-selection of which features they are going to pull in, probably, and then they refine that in their teams. And then retrospective, of course, there's one sprint review, right? Nobody cares about individual components, so the review is always on the integrated, working, tested increment. And then there is this 2-step retrospective. Of course, the teams need their own retrospective because of team building and engineering skills improvement. But that's not enough because we need to improve the whole scaled Scrum. So there's a second retrospective with representatives again to take the stuff that came out of the retros that are out of the scope of the teams, for example, and then fix that across teams. And if you look very closely, this has been going on for quite some years, there is an organization that has this. And it's called Nexus. All right? So.
Okay, I made some pictures of how we actually do it. We can make nice PowerPoints, but everyone can make PowerPoints. We have our sprint board. We have it electronically, but we also want to have it physically, to physically move to stickies when we stand around it. So we print the electronic the electronic features and stories on white stickers, and that we pull on stickies. You see the large ones as the color code for the project we are working on, and then each team has its own color code for the smaller stickies. So then what we see then is we move from top to bottom, that moves over the sprint board. And it actually does. That's the first one. When something is finished, the story is finished, we put it on a timeline. It's on the other side. So at the end of the sprint, we have the timeline, and we take that to the retrospective to have a visualization of what happened during the sprint. And not only the finished features and stories are on it, but also other important things that happen. There's someone turned 50, so we make a picture and put it over there. Of when someone is annoyed about something, or when a lot of people take off because it's holidays, or the sun is shining and the work does not get finished. All those emotions are also written down. And then you actually see how the work moves from left to right over the wall and to the timeline. And that's how we are standing together each morning. And this is the sprint review. You see no people because I was standing in the front when I took the picture, but they are really behind me. This is our, what we call it, delivery room. It's with computers, and there we can remote access the target system. So we can show the real live demo during the sprint review. And on this picture you see the part of the screens where the radar screen is on.
All right. Oh.
And effective retrospective, you told already, each team has its own retrospective. And the day afterwards, we have the department's retrospective, in which the Scrum Masters show up. And they mainly discuss the items that the teams cannot solve themselves. What they can solve themselves, they're self-organizing, they solve themselves. But if it's needed to be picked up in the larger organization, it's discussed there.
All right, I see that we have between 10 and 15 minutes left. So I just wanted to share something about management. So they took this step back. They don't play PO roles anymore. Some of them took a more coaching approach. And I just want to share this picture because this is actually Sandra. It's on the other side, as you can see, and the bottom of this gentleman is the head of the department. And this is a picture of them doing. It's true. This is a picture of the management team doing the Scrum, and I took that picture and then I printed it and put it on the walls during the initial months just to see, okay, we are really serious. So bottom up, we're serious, but top down, we're serious also. So that's it's a funny thing that I wanted to share with you. So, well, you have to do all the talking again, I guess.
I have.
Ah.
Okay, what did we achieve? I wanted to start with the first thing. We heard this morning about you need to have passion, and you need also to have potential, and you needed to have something else too. But we really like to work. We together make now this digital radar processing for all those radar systems. And I, as a manager, I'm proud of that. But all those engineers, we together do this. We have fun. We like it. What we in the beginning wanted, we have. We have now real clear status information on where are we. When a feature is finished, it's finished. Not only the separate components, but the total. And everyone sees it. Everyone can walk in that space where we are sitting and where the features are moving or not moving. That we can have the good priority setting, fine-grained we discussed already. We have the knowledge sharing. And last but not least, now we do the integration immediately when we do the component team development. We make better quality products. In the beginning, all the components were finished, and then the tester had to start. And it took months before we really had the total working on the real system. And the last time, it was only a few days. It can sound long, but a few days is really fast for this type of systems. And I heard one of the most septic engineers say, gee, management is not that those guys far away, but they are more becoming part of us. And I like that.
Great.
We are not finished yet. What I really like to do is we still have that, like most Dutch companies, individual salary system. You say to one guy, how good are you and how much salary should you get? But when you work together as a team, that you shouldn't do that anymore. You should say as teams together, how good are you doing? And then maybe the team members can divide the money between them. We are not there yet, and I think we will not be there this year. But at least we made now team objectives, that the team together defines what they want to work on. And you don't need to have the salary, but you can also say the best team gets a blanco check for a nice evening. Those things we can do, and the salary system will take more time. And this one, you made the drawing. Maybe you can say...
Oh, yeah, so the single component teams are bad, so let's keep it at that. So we want cross-functional team, but we also want cross-component team. So what Thales is currently doing, what is very scary for mathematicians and so on, so hey, other people from other teams can look at your code. That's one thing. This was already big, but also they can maybe change a little bit of your code. So teams will become cross-component. So the more cross-component they get, the more agility will be introduced in your organization, right? Because people will do multi-learning. They will become multi-skilled. Your single point of bottlenecks will be fewer. So this is the next step that we are currently working on. So here are some examples of teams doing cross-component development. And that means that dependencies that you have on the front, the requirements are actually moved to dependencies on code. And when the dependencies are on code, it's better for us to manage them because we have tools for doing that. We have now cross-component teams. We started with single specialty teams, just like Taylor tells us, and specialize the work and then optimize the parts. Now one of the things to work on if you want to scale Agile is you have to create cross-component teams, right? I'm sorry? Feature teams are cross-component, yes.
But full feature teams, that FPGA engineer developing hardware and the mathematician who has a PhD in that they really can do it all. So now we are working on parts that overlap. So not feature teams, but teams that can handle two components.
Yeah.
First step.
Yeah, so it's not, because it's hardware and software and iron. So a feature team, well, a guy who makes iron and does chips and does mathematics and so on. I think, well, where's the border? This is not the border yet, but it will never be a team that can go end to end. Never. At least, unless you have 7 Einsteins, but they are not in abundance, I have noticed. So that's the thing that we're currently working on, so the cross-component teams. And maybe this one.
But we also, the scope of the team, so they are working also on other parts, help other components, and we want to integrate what they are doing. So the functional tester is not yet part of the department sprint, but they pick up a feature immediately when it's finished, instead of waiting on the 3-month cycles. So we want to extend the individual teams what they are doing and the total of the department sprint, what's involved.
Yeah, so there's an increase, right?
And that's an increase, and the other part is the cooperation with our surrounding departments. In fact, the FPGA engineers is between hardware and software. They are Scrumming already. That the electronic department, board design, will go to Scrum, not yet, but involve them in our monthly cycles. And we are working on that right now. And when we do that, when we work more together, we can optimize as a group of departments what the customer wants and when he wants it.
So what the takeaway is, what we want to give to you as a takeaway is, we had the same sheet last year. I don't know if anybody was here. So these people from Thales, they made this up on their own. So I didn't tell them anything about how to do it. I just told them about what the goal should be, how they could do something, what the principles are, and so on. And that's a very important thing. So they started from, well, you know where they started from, and they built this step by step organically, trying things out themselves, therefore taking ownership for things if it worked, and therefore the change is lasting. It's a lasting change. So there are people who talk about, okay, we do the change and then we have to make it stick. Well, if you have to make it stick, you're doing the wrong thing, right? Because the change should be created by the persons themselves doing the work. And that's a very big takeaway that I want to share with you is, if you can manage, if you can fix it, or I don't know how you want to call it, that the people themselves make the changes, then they will stick and then they will be supported and then people will take ownership. So unfortunately, I was talking to Jutta a few minutes ago. People want recipes and so on. There are no recipes, unfortunately. So you have to take the stairs, and you cannot take an elevator to scaling Agile. So this is our story. We do one sprint, one increment, 9 development teams, about 75 people, and it works.
Yes.
So I don't know how many minutes are left. 5?
2.
2?
Any questions? Yes.
Oh.
Wait.
Can I propose that he is not allowed to?
No, you can't. Why you think I'm going to trip you up? By the way, I just want to say that was absolutely wonderful. It's good to see the two of you on stage talking and doing the presentation together. My question is, and by the way, my name is Nana, aka Morpheus. My question to you guys, what was the greatest challenge, or perhaps what was the most resistance that you faced, and where was the resistance?
Only one.
So,
One part was the component teams. This is our component. Let's work together. Don't disturb us. The other part is not my manager, but the even higher managers. See, Agile, but that's for web. What are you doing? In the first sprint, we didn't make it. See, it fails. It doesn't work. To have the courage to continue and keep on improving. I think that's one. That were a few of the challenges. What do you remember more?
I can add one. One that I want to share with you is, wow, why should I help you? Right? I am a tester. You do development, right? I have my tester done. I'm done. So why should I worry about delivering working product every sprint? My job is testing, your job is developing. You develop, I test. The mindset, that change from what you're developing is worth 0, testing is worth 0, we are not being paid for that. That change in mindset, that we are paid to deliver stuff that our customers can actually consume. Yeah. That was one of the biggest stuff.
Now, department sprint has highest priority, not each team's or each person's individual objectives.
One question over here.
Yeah, thank you. How is that different with the testing and development, with the hardware, the software, and the iron, as you call it?
Can I ask a question back? Okay, what do you mean? Why? What is different? What is the what?
You said like his job is development, my job is testing. So I just stick to my testing, and you stick to your development.
Ah, okay.
How is that?
So it's not different in meta, but it's different in stack. So those guys have really different cycles. They have really different development stacks. They have really different technology. So it's very different. Testing and developing, we are developing the same thing. We use the same tools and the same development stack and so on. But those guys doing chips and so on. Well, I don't know actually what they're doing, but it doesn't look like anything I know.
Like board design, they have those cycles of ordering a proto board, and then you have to wait for a month, and they have to be on some parts, not first time right, but at least second time right. And it's difficult it's more difficult to bring in agility in that than in software development. Yes, we.
Can you repeat the question?
We've seen also that in hardware development, also prototyping becomes something that you simulate, and that can help to be also agile in hardware development.
We are working on that. Some of my colleague managers in the hardware development part like this, and they don't do Scrum, of course. They are not software, but they have a wall with stickies that move from left to right. And
they got the
stand
stickies, right?
not every day, but every other day they are grouping together around it. So
It's a nice first step, I think. Yeah.
yes.
What was the cycle time of this transformation? Means from the moment you begin the transformation and the moment you get the first benefits? And did you measure the benefits you get from this transformation?
So 2 questions.
Yes.
You want me to answer or do you want to answer?
Oh, the cycle time is the easiest one.
Okay, so at the time, I think when I came in, so let's start when I came in, because I don't know the other ones. When I came in until we had the first sprint that delivered something workable, integrated across all teams, I don't know, 6 months, 7 months?
Very quick, yeah.
Yeah. But okay, it was 90% failed, right? One little piece was successful. That was after 7 months. Yeah. And the second question was?
Were you able to measure the benefits, for example, using EBM or something just to justify the investment you made to change?
No, we did EBM, but afterwards, so not in the first wave. We tried to measure time until release to system testing. So we tried, and I don't want the man in black banging on my door at 3 in the night, so I don't know if I'm allowed to talk about this. So, but Sandra, she knows all the rules.
Now it's difficult to measure how much profit we made, but because in parallel we generate 70 to 80% of our code currently, and a lot of things in parallel. And what I say, the time on the system, the test time, and the failures that come back, everyone says it seems to be less, but we never really measured it. So I have no hard figures.
We have the testing. It took months to stabilize. Now it takes days.
The weeks, days. That's something hard.
Yeah.
We are now measuring the problems that come back, and in fact, the maintenance after our testers tested it. We had a certain percentage. I don't know what I'm allowed to say, but it's now only to that. Maybe it's already too high for the outside world, but that's now only two-thirds reserved in the budget. And it seems to be more than enough. So the failures that come back are really less. And how much money it is, that's difficult to say, but it's no disturbance, no...
Thank you.
Thank you.
One last question.
What's the biggest challenge at this time?
There are 2 things, having the testers involved and with our inputs department. They should be involved more, then we can make real steps.
And we're talking about testers at not the software testers.
Outside the departments, I think we can make real profit if they are more involved too.
Okay, thank you very much. Give them a big applause. Of course, we also cut a lot of presents for you. Dave is going to bring them.
All right, red wine. I know a colleague who likes red wine. There's one, and there's another one. Thank you.